actuators. This is the flapper actuator. This would correspond here to parallel electromagnetics. I mean, parallel permanent magnet, repulsive diamagnetic permanent magnet actuator. So that will move here for flapping up or down, or flap for Ornithopter. So it's here, and here's the other. I used the surface back of copper, rather than something that's magnetic or not magnetic, and that will flap for the central. I bounded it with permanent magnets within the side. The central actuator, there's three actuators that are wound together. One is central right here, local to the center, and that there's the repulsive magnets between the gauge. I use the actuator to move away from the magnetic field. This is repulsive, so don't stick to the unit, but actually move away from the magnetic field. I'm going to be using an AC charge taser to tase the electrode, which I'm going to put aluminum over the surface of the permanent magnet, and I'm going to put just aluminum there. And I'm going to be using a taser with a capacitor and apply the voltage to a metallic rod. It's going to be localized through the system of the actuator. This will be a latch, the returning spring to move back and forth. That will strike against the surface and cause the permanent magnet to move away. Okay, so therefore I'm using the magnetic propulsion, magnetic suspension, and creating an actuator. This is going to be my actuator engine, EEG, electrical energy generator engine. I'm going to be using 8 currents in order to pass through, along with central nickel-neodymium, nickel-neodymium permanent magnet, able of 52 newtons and 2.6 kilograms, which is 5 pounds and 83 ounces. Magnetic propulsion method for the suspension of a faceplate, the Iron Man faceplate. I'm going to be using repulsive magnetics to move the object from the surfaces by using the weight of the density of a permanent magnet, and is a repulsive emission as it being common to the subject to move away from the magnetic field. So the force of the kinetic energy of the gas between the object being lifted into the air. Now the actuator is the magnetic gas. However, electronically by a modified permanent magnet, operating in 2 forms as electromagnet and permanent magnet, exhibiting a permanent magnetic central. The attractive force of the electromagnet pulls the object that's being lifted into the air closer. However, but the closeness moves away the object from the magnetic field. So, therefore, in this area, which is which is going to be used with 2 types: one, permanent magnet, electromagnet, and the 4th kind, which is DC, high voltage, DC, AC current, using a voltage booster. This voltage booster, which is used for tasers, will tase the iron sheet, electromagnetic sheet, that exhibiting the coil and the permanent magnets in the central. So anytime that the magnet comes into the field, having a rod, which is cathode rod, bearing the phase point wires of both on the parallel rod, the electrical energy, once it touches the surface, will force it away greater than the strength of repulsive electromagnets, repulsive electromagnetism, and greater than the permanent repulsive magnetics, and it will force the object, this being coupled to the object, being moved into the air. Once it touches the metallic surface, it will electrocute it and cause the electromagnetic pulse to move away from the electromagnetic field. So as soon as it's tased, it will move away in a linear motion away from the magnetic field. And the weight or the velocity of the electrical energy in the responsive calming collision is greater in force than the inertial mass and the gravitational mass, which enables it to lift it into the air. If done in modulated the electromotive induced currents ultrasonically, it will, in ultrasonic speeds, it will cause electrical energy to displace the flux of density and ultrasonically cause the movement to rapidly move away from the magnetic field and away from the DC charged iron. So the DC charged iron will immediately try to move away. As long as it constantly tases it, it will force it away, regardless of its inertial mass. Now, here I have, similar to this flat wafer module. This is another part of the module where I'm using the plasma, the phase rods, within the system to allow the plasma to fill to as far as a spark gap within the cylindrical hollow aluminum block. And the aluminum block is coiled with two types of turns of coils, which are moving in the same direction upward. The phase point, which starts at one end and winds up to the other end, as if moving the electrical energy upward. However, the rod is faced in a parallel from alongside one another, and causes the spark gap of ions to move within the system. Now, I have permanent magnets that are also faced alongside it, where the repulsive force is focused towards the core, enabling these parts to breathe out ions. However, this diamagnetic is not connected to, it's repulsive to permanent magnets. So where in a magnetic field, it will cause this magnet to move away from it. See how the magnet is turning away from the magnetic field. So what happens is, because of the common side. So when I buckle this in a permanent state, the electrical energy that flows through the system by the voltage capacitor, high voltage, will this induced inductor, copper winding coil, induce currents in similar of the voltage and cause the kinetic energy to try to displace the common attitude or gust of this permanent magnet, which should be in more weight than its inertial. As far as gust, the gust should be more strength than its inertial mass, enough to move the object by itself. Now, the object of the inertial mass, that means the entire of the unit, the entirety of the unit. So the gust should be greater in strength and density to move the object. Now, this one I have going in a vertical position, whereas if I'm using it onto a faceplate, it will be embedded within alongside the gorge, and therefore a magnet will be placed on top. So the electrical winding energy will move it away from the magnetic field, causing the plasma to receive inductions to lift it up into the ear, carrying the inertial mass, carrying the mass of the magnet, the repulsive displacement that is moving this way, and this actually moving this way to force away this magnet. While it's forcing away this magnet, the magnet is dragging the object along with it while it's being forced away. Now, I also have this one, which is more horizontal. It's fixed horizontal so that it can be like frontal or is in a vertical position of the faceplate. So the inertial mass, the gust, is greater than the mass of the object. So I'm going to apply this here to move it away on its right polar, so that I have to turn it upside down to move it away from its polar so that it does not connect. There is also iron that is localized under here, so it's moving away from the permanent magnet and trying to join at the iron that is alongside that surface that it lies on. See, the gust is greater than its inertial mass, causing it to move away from the magnetic field. So when this is activated, it's activated in the same similar with the plasma spark gap within it and the ions that induce the current on the exterior. And as far as the permanent magnet that is local, fixed permanently on top of the surface, on its opposing side going upward, so it repulses against the electrical winding energy. And as of a coil shall be central within this vector. That's later when I apply the permanent magnet, which is a large magnet, nickel neodymium, having at least more kilograms force than this magnet. This is only 2.6, which is 5 pounds. So I'm going to use, and I know that the inertial mass of all the materials is not more than 5 pounds. So while it moves it away from the magnetic field, I'm going to hold it still because it only has a certain amount of emitting vector. So if I go slow, I'm able to move it away from the magnetic field. So therefore, when electrical winding energy, which broadens the magnetic field through induced currents, causes a large amount of electrical energy winding, which will move the magnets away from the magnetic field. So therefore, while the magnet is escaping from the electrical winding energy, it's also dragging the inertial mass along with it. So that's what is going to be used on the faceplate. My name is Jermaine Morton. Goodbye.